Knox Game Design, September 2022. Reading text files.
Welcome everyone to Knox Game Design for September 2022. My name is Levi Smith. So this month I'm going to start out, and just for an announcement, we're having the Knox Game Jam, the Fall 22 edition. We usually do this twice a year, kickoff. I'll be meeting at Panera Bread, and it'll be this Friday, September 30th, 2022. Get together at 6 p.m. Eastern Time, and we usually get together, talk about the theme, and brainstorm ideas and things like that. I just kind of came up with some guidelines. You're welcome to follow these or not, but the goal is basically just to create a game in 48 hours, and you can make a game on that theme, or you can just make whatever you want. If you want an extra challenge, don't use any pre-existing assets like sound files, sound effects, music, graphics, or models. Do everything during the game jam. And you can also submit your game to any other game jams as you wish. Don't feel like that you're not allowed to submit to any other game jams. So in this game jam, there'll be no voting, judging, or ranking, but again, you're welcome to submit your game to any other game jams that may have voting, judging, or ranking. No prizes. Your game is your prize, and you're welcome to use any game development environment or engine you want. Typically, we do Unity or GameMaker, but we've had some people do processing and Unreal. Some other examples are Godot, MonoGame, Allegro. Typically, we do use game development environments that you can use to make a web build where you can play the game in a web browser. That just makes it easier for people to play your game. And I guess that's the one thing. It's nice if everybody just plays everybody else's game. And typically, we talk about what we've developed at the next monthly meeting, so we'll try to do that again as well. That's coming up this Friday. Hope to see everyone there. If you need more information on that, go to knoxgamedesign.org, and then we have a link to the meeting location and details and everything else. So this month I'm going to be talking about reading text files in your game. I'm going to show how to do this, just basically give an overview of reading text files. So I'm going to go over how to actually implement reading a file in 5 different game development environments: Unity, GameMaker, Godot, MonoGame, and SDL. So that should give an overview of a few different types of ways that you can do this. But here's the basics. Whenever you want to read a text file, so this is basically just like, hey, you want to read in some data. And in this example, I'll be using the text data to make a maze, but you could possibly use reading text data for many other things in your game. We want to read through each line in the file, and these lines are going to be separated by a new line character. And I'll just go ahead and say you got to watch out sometimes, like depending on what platform you're on, either Windows or a Linux style environment. That new line on Windows is going to be a character turn in the line feed, so it's actually like 2 characters. And on Linux based systems, you're just going to have, I believe it's the carriage return only, so it's only 1 character. As we go through each line in the text file, we're going to increment the row number. We're going to keep track of the row and column. Like I was saying, this is going to be kind of like a maze or walls for a maze. And then for each row, we're going to reset the column number back to 0. And then for each line, we're going to go through each character on that line. And then for each character, we're going to increment the column number by 1. So in this example, we're looking for the pound sign, the hashtag symbol. If it matches that, then we're going to instantiate like a wall in our maze. And by the way, for each line that we read, we're going to stop at the line length. So yeah, basically the exposition for your wall is going to be the column number. The Y position is going to be the row number. But you got to watch out in game development environments where you got a Y up coordinate system. You got to take the total number of rows and then subtract the current row, because usually when we're reading a text file, then it goes from top to bottom, from the least row number to the greatest row number. But if your coordinate systems are flipped, then if you don't subtract the row number from the total number of rows, then your maze will end up looking upside down. So that's just something you got to watch out for. Yeah, so here's our example text file right here. It may be kind of hard to read, but it says Knox and pound sign. So there's the K and the N and the O and the X. Just really simple. Kind of looks like the logo for the podcast here. So the first example we're going to look at is Unity. So basically what you need to do is take your text file that we've created in our text editor, use whatever text editor you want, VI, Notepad++, regular Notepad, whatever. But what you want to do is copy that into your assets. And I believe it needs to be in your resources folder. I know if you are making a web build of the game, then it's better to put it in your resources folder. That way your web game has access to that text file. Then what we want to do is take that object in your resources folder, then assign that to a text asset. I don't even think you have to import anything. I think you get text asset by default whenever you start a Unity program and you open up when you create the C# script. Then it's pretty simple. You just use that text asset .text to get the contents of your file as a string. Then we can split that string into multiple rows by using .split with a capital S. And you can specify the delimiter character. I think by default it just uses the new line \n. You can put \n in there if you want. Then for each line in our text file, we're going to leap through all the characters. And we can do that with a for each, then do char C or whatever you want to call it in your string, and that'll return the characters one by one. And then whenever one of those characters matches that pound sign, then we're going to instantiate a wall prefab. Yeah, so we got a text reader object, and that just basically holds our text reader script. Over here in our hierarchy, you can see I've created the resources folder and basically just pulled it in to the window, that Knox.txt file, and that's just a file on our file system here. And by the way, I'll check in this code into our software repository, but there's our Knox text right there, and you can see that's where the Knox. It's kind of hard to read in Notepad, but that does say Knox right there. So you just basically grab this text file and drag it in over to your assets and into your created resources folder. We have a prefab, which is a wall. It's just basically a default cube, default Unity cube. Pretty simple there. And so then we just have our scene, and then we have the one text reader script. So keeping it simple. So in our text reader, we also define, in our text reader script, we just define the wall prefab right here. So if we go look at the script, we have our public, and that's our text asset right there that's going to hold a reference to the text data. Then we have a game object wall. That's our prefab right there. So once you define those two, then you can drag that prefab in from your assets over here up to your text reader script right there. Get that wired up right there. So yeah, when we start, I'm just going to call this function called parse data. That's going to be doing all our reading. So we got a string called stir data, which gets the text out of that file. Then we have our row and call int variables. We're going to set row to 0. Then we're going to take our row data. We're going to take the stir data, then split it on the new line character. We're going to save that into a variable, a string array variable called stir row data. So we're going to load all the lines in that text file into this string array right here. Then we're going to have 2 for each loops. So the first one's going to loop through the rows. So for each stir line in the row data, we're going to set the column to 0. Then for each character in stir line in each line, we're going to check and see if that character equals to £. If it does, we're going to set up a vector3 position variable. So we're going to set that to the column for X, 0 for Y, and then for Z, we're going to take the length, because we've got a positive Z, or kind of like the positive Y, we're going positive in the Z direction. We're going to take the total number of rows and subtract off the current row. So I'll get that lined up correctly. So then we're going to instantiate our wall object using that position. We're just going to use the default quaternion identity. So for each character, we're going to increment the column. Then for each row, we're going to increment the row. And that's all there is to it. So if we go back and we hit play, this is what it looks like. So that's completely red. These are all prefabs. You can see over here on our hierarchy all the prefabs that created of walls. But yeah, you could use this for a simple game. Like if you had a maze style game, you could come in here and try to find your way through, put a boundary around it or something. But yeah, pretty simple way. I know I've done plenty of game jams. I just need to make a level really quickly, so I'll just make a little text file, use this process for making level for the game. And yeah, so I kind of took this example from like Sokoban using the pound signs from that's kind of the standard for Sokoban, but you could also have other characters represent like a player or enemies or an entry point or exit point or a door, whatever you want. But I think it's much easier to go in here and use a text file. Like I could go in here and go to resources and open up this Knox text. And then like if I wanted to add like an exclamation point, I just add those characters right there and then save, then rerun it. Now we got Knox with an exclamation point at the end. So yeah, just with that really simple change, I was able to lay out those new walls in the game with very minimal effort. It's much faster than trying to go in here and actually like lay these out manually within Unity. So on this slide, this is the same thing taken directly from the code that I just shown. And there's the example we looked at there. So the next one we're going to look at is GameMaker. So what you got to do is you take your file and you set the file in included files. This is in the data file subdirectory of your GameMaker project. So then you basically create an object for reading the files. And always remember, this is the thing I always forget, is to take that object and pull it into your room. If you press play and you don't see anything happening, make sure you pull that your game manager object into your room, or else it won't do anything. So there's a function called file text open read. And then you just pass in the file name. You put that in a create method. And then you can get the line data with file text read string and pass in the reference to the file. And then you can create instances of your object using instant create layer. Then you pass in your X and Y coordinates, the layer, which is either like the name of the layer or an index. So then you can just pass in 0. Then the object that you want to instantiate. Yeah, so here's our example GameMaker project right here. So we got an object right here called OBJ text reader, and here's the properties over right here. It really doesn't have, I don't even need to have it as visible, but it doesn't have any sprites or anything. It just has a create method right here. So if we go over here and look at the code, this is the code. So we're going to create a file, and we're going to open up Knox.txt. And oh, by the way, it's up here. You got to click, I believe, on these triple lines right here. Go into included files, and that's where our Knox.txt is right there. So if we actually look in the GameMaker project, it's just right here, data files, and that's our Knox.txt right there. So yeah, kind of the same thing going on here. We got a stir data where we're going to read in the lines, and we're going to set our row variable, int variable, to 0. And so while we haven't reached the end of the file, we use file text EOF while we're not at the end of the file. Then we're going to use file text readln, read a line of that file, and store that in str data. And one thing to watch out with GameMaker, it starts out the arrays start out with 1, so we're going to set I column to 1. If your output is off by 1, make sure you're starting out at 1. So while, then we're going to go from 1 to the string length of your line data plus 1. Then if the character string char at, then take the stir data at that column. If it equals a pound symbol, then we're going to use instant create layer, like I was talking about earlier, then I column times, and these walls are going to be 32 pixels wide, so I call times 32. Then they're also going to be 32 height, tall. We're going to do I row times 32. Then we're just going to instantiate at layer 0, and then we're going to pass in this OBJ wall. So OBJ wall is defined right here, and if we look at it, it's pretty simple. Just a white square, 32 by 32. And like if we're making a real game, you might want to check like solid so you can't go through it and things like that. But we're not worried about that. That's not the point of this demo. We just want to have it like instantiate on our screen. So for each of those characters, we're going to increment column by 1. I call add and assign 1. And then after we're done reading through all those characters and we're ready to get to the next line, we're going to do I row, add and assign 1. So after we've looped through all the lines, then we're going to do file text closed and reference to the file, just to clean things up. So if we play this, then it's just going to make a blue screen, and there's our Knox right there. So yeah, it's kind of one off because we're starting at index 1 instead of 0. You can see right there, we got Knox right there. So by the way, we do have like the default room over here. So I just set the color, background color to blue. You can make it whatever color you want. And this little guy right here, the little question mark, that's where I drug in this OBJ text reader into the game room. So if you don't have that guy right there, and we also have a sprite, so I just used the default GameMaker sprite editor and just filled it with white. But those could be nice textures or sprites or bricks or whatever you want them to be. But yeah, that's basically it for GameMaker. Here's just the slide showing the code that I talked about right there. There's the GameMaker. So next on the list is MonoGame. What we need to do is add your text file as an existing item. This is one thing that threw me off when I began implementing this. I thought you would add it to as an asset into your I believe it's MCGB as a content item, but that's not the easiest way to do it. It is possible to do it that way, but you have to like create your own content reader. So that's not the simplest way to do it. So it's easier just to add it as an existing item. Then in the property, you set it to copy always. So you make sure that's included in your game development package. You need to import system.io, And so we're going to read each line with streamReader.readLine. Then we're going to read through the characters in the string with a for each. And the same thing with Unity. It's all C#, a char C in your string. So here's our game, or MonoGame project right here. So you can see in our content we have our Knox.text. So you just add that by, I believe you go right there. You can add an existing item, and then you can go like find or you may have, you got to, one thing you got to do is you got to switch it to just like all files, and then you can find your Knox text right there. And then you import that. And then, as I mentioned earlier, click on that Knox text and make sure you go into properties and copy always, or else it won't be included in your game package. But it's pretty easy after that. Like I said, include system IO up here. This is kind of standard MonoGame stuff up here with the sprite batch. We're going to create a list of walls. So I do have like a wall game object, just a wall object that has an X and Y position, and basically has a draw method. You pass in the sprite batch. You do sprite batch and dot draw and the texture. So I'm going to have like a static dictionary of textures. I found that's the easiest way to do textures in MonoGame. Then we're going to draw it at that object's X and Y coordinates in color white. So white basically just means the color of the sprite. You can set that to other colors to make it tinted. So in our constructor, we're not doing anything special. In initialize, we're going to make our list of walls. It's going to be empty to start out with. So here's where we're reading in the data. Use the using keyword. Then we're going to have a stream called stream. Then we're going to use title container, and then dot open stream, and pass in the string Knox.text, whatever you called it in your whatever you called it when you imported it over here. Then we're going to do another using stream reader. Then we're going to do new stream reader, then pass in the stream that we created. So we're going to have a string variable for each line, stir line, then int for I row and I column. We're going to set I row to 0. Kind of the same thing we've been doing with everything else. So while reader.readLine does not equal null, we want to assign that to stir line. We're going to set our column to 0. Then for each character in that stir line, if this is the same thing as Unity, if C equals double equals the pound character, then what we're going to do is we're going to create a new wall object. We're going to pass in the X and Y coordinates, so the column times 32, so we're still doing 32 pixels for the width and height. So I call is your X position, so we do I call times 32, then I row, which is our Y position, I row times 32. This one we are doing Y down as Y goes down, then the values get greater. So we don't have to worry about flipping it. So in our walls list, we're going to add that wall. Then for each character, we're going to increment the columns. Then for each row, we're going to increment the rows. And that's basically it. Here's our load content. So this is that static textures dictionary that I was talking about. So we're just going to import that wall sprite. It's called SPR wall. And I do have a talk on creating games in MonoGame if you're interested in knowing more about that. But just know that you got this MGCB editor, and you basically just go into the content, you add an existing item, then it'll let you select your PNG file, graphics file right there. Then you're able to import that into your dictionary of textures, which we only have one texture in this example. But if you're making a real game, you'd have lots more textures. So this is all default stuff right here. So in our main draw method, we're going to set the background. This is default cornflower blue. So before we do base draw, we're going to do sprite batch begin. This is kind of standard XNA MonoGame stuff. Then we're going to loop through all the walls in our wall list, and we're just going to call wall.draw and pass in the sprite batch. Then after we're done with that, we're going to call sprite batch in. So we press play. Then there it is, right there. So yeah, that's reading all those objects out of the text file. Like I said, you can go into Knox. Yeah, so here's basically just the code on the slide that we just went over. And here's the output right there. So the next game engine we're going to look at is Godot engine. So it's really similar. So you need to add the text file to your project folder. And this is one thing that threw me for a loop. It won't display in your res :// file system display. So we're going to create a new file object using that res :// knox.txt file name, create it in read mode. Then you can get the lines with f.getLine. So here's our Godot project right here. So I got an object here, node called Game Manager. Then I have a standard camera looking downward right here. The root node is called Spatial. Yeah, so if you look over here in your file system, you won't see a knox.txt file. But if you go look in your data directory for your Godot project, see knox.txt right there, just in your main Godot folder, but it won't show up in your file system. I have a box.fbx, so I created this in Blender, just a simple box, 1 by 1 unit by 1 unit by 1 unit. Imported that in, and then I created this tscn file right here. That's kind of like an instance of your, or it's kind of like a prefab in Unity, but it's called a tscn. So you can actually open that up. It's going to be like its own scene. So you got like a scene right here with just the box. So that's our box.tscn. That's going to be our wall right there. And it automatically imported like the material from Unity. Look at our object right there. But yeah, just know that your prefab is a separate scene called box. So our main logic is in Game Manager. So you just click on this little scroll right here to look at your script. And I'll pull this. Yeah, so here it is. So your constructor initialize is just called _ready. And this is a lot like Python where tabs are significant. So we're going to have a function called parse file that's going to read through it. So we're going to have a variable called scene wall. That's where we're going to use load, keyword load, and pass in a string res :// box.tscn, the name of that scene containing your box or your wall. And we're going to have a variable called wall. We're going to keep the instances. We're going to have a variable called stir file, which has the location, just your text file, knox res :// knox text. Again, it won't show up in your file system. I don't know if that's a bug or what, but it doesn't show up there. So now we're going to have a variable called f for our file. We're going to have file.new. Then we're going to do f.open, then pass in the location of your text file, stir file, and comma. Second parameter is file.read, read it in all capitalized. We're going to do the same thing with all the other languages. We got row. We're going to set iRow to 0. And while not f.end of file reached, the file EOF_reached, then we're going to store current line, f dot get read line, and a variable called line, then I'm not sure why we're doing a space. I don't know if that's needed or not. Yeah, so then we're going to have a variable called iColumn, keep track of columns, set that to 0. So while the column iColumn is less than the line length, it might be why we add the extra space at the end. Offset the we're going to do if line, then in bracket notation, pass in the column number. That equals the pound sign. Then we're going to create a new wall object. So we're just going to do wall, which we created, defined up here. It's kind of like our holder for the wall object. So we're going to do scene wall. Scene wall was where we loaded that box scene. Scene wall dot instance. So that's kind of like a instantiate in Unity. So we're going to do scene wall and instance. So then we're going to do wall dot translation. This is kind of like in Unity doing our transform, game object dot transform dot position. So it's wall dot translation equals then a vector 3. We don't need a new keyword. It's just vector 3 open. Then the X position is going to be our column. Then our Y position is going to be 0. Then our Z position is going to be the row. So this has got a positive Z going upward or into the screen, I believe. So we don't need to subtract off the total number of rows. So then we're just going to add that using add underscore child, that instance of that wall object, to add it to the scene. So we got our I column. We're going to increment that by 1 for each character in the string on that line. Then after we're finished reading through all the characters on that line, then we're going to increment row by 1. Then after we're done reading all the rows, then we're going to do f.close to close our file reader, and then you can just like return there to. And I don't even think you really need that return right there. So let's go ahead and play this. So there it is right there, Knox. Go back. I think no, it doesn't actually instantiate. It's not like Unity where it'll instantiate it in real time in your game viewer. So you just got to press play and view it in your game view. That's one thing that's kind of annoying with Godot. So if you want to actually like adjust your camera, you just kind of got to go up and move it, then press play again and see how your objects are laid out. There's no real-time view of your game in the editor mode when you play it that I know of. There could be, I just don't know. Yeah, but that's basically it for Godot. And so it just took me a little while to figure it out because I'm not a Godot expert, but it's not difficult once you know how to do it. Probably if I did Godot more often, this would be really, really simple. So going back to our slide, so this is basically code that I went through right here. There's the output right there. So last on the list is SDL. I wanted to do like a low-level game development library. So this is C. So this is kind of like standard C stuff. So we're going to use standard io.h. So you use our file, all capital file star, pointer to a file object, then use fopen, pass in your file name, and then a string with just the lowercase r to make it read only to open the file. Then we use fgets to read each line. So we then pass in our character array, create a character array to hold each line, and the number of characters to read. So this is where it's kind of limited. So we're limiting how many characters we can read per line, and then pass in a reference to the file as a third parameter. But I do mention, I think the very last line, you can use fgetC to go through every character in the file. Then you just handle whenever you reach a new line character, increment the row then. But I'm using fget, so there's two ways you can kind of skin this cat. So you loop through all the lines until fget equals null. Then for each line, we're going to loop through the characters and the character array using our standard C bracket notation. You just got to ensure that your each line has enough size, it's big enough to hold all the characters in the line, else bad things will happen. It'll actually try to read that number of characters, then it'll try to do a read again for the same line, then things will get wonky from there. Then you just use fclose to close the file after read all the lines. Okay, so kind of wanted to do a public service announcement right here. So what I'm using to do SDL, I'm using MSys64, and this is the installation right here. So MSys64 is a lot like MinGW or MinGW. That actually includes that old one. But the one that I'm using is MinGW64. So I just dragged that onto my desktop. By default, they'll try to put msys2.exe. But if you start at MinGW64, then up here in the output, up here in your output, in your window, it's going to say MinGW64 instead of MSys. And I think this works with the SDL libraries a lot better. So to install this, you're going to use the package manager, and then, well, first of all, you're going to download MSys2 from msys2.org. I'm not going to bring that up, but you use the package manager, then do -S. Then this is really important right here. Do mingw64 / mingw-w64-x86 underscore 64-GCC. So GCC is our standard C compiler. We also use the package manager to go ahead and install VI, which I created an alias. You install VIM, VI improved. I just created an alias for VI to VIM. Then we're going to use the package manager -S. Then we're going to install mingw64 / mingw-w64-x86 underscore 64-SDL2. Then to compile a program, we use GCC, then our text reader, our source file -O, our output file. Then we're going to use the backtick SDL2 -config space --C flags -LIBS, and another backtick. Now here I mention again, make sure you're using MinGW64, not MSys, or this, it'll throw errors whenever it tries to compile and link your file. So that's one thing that's a little bit confusing about MSys2. They got like different, what they call environments. And if you're not using the right environment, you'll be getting the wrong libraries. So the reason I went through all that is because I did a talk on SDL a year or two ago and wasn't able to figure out how to get this running in the latest version of MSys2. So they got it pretty simple now. Just got to make sure you're using that right executable. They got it pretty simple, just a couple using the package manager to import the SDL libraries. So let's take a look at it. And there's our SDL right there. So yeah, we can do a cat Knox. I think we can do a cat. Yeah, we can do a cat. We can do cat Knox text. There's our text file right there. One thing I had to do is I had to convert our PNG to a BMP. There are additional libraries. You can go back and watch my talk on SDL. Got the video online. And I go into the details of all this, but just to make this simple, I'm going to use the standard BMP importer. I think it's got to be in the right format, and I can't remember that off the top of my head. But I think it's either 16 or 24-bit. If it doesn't work, just change it to the other one whenever you're exporting your BMP. I use GIMP. GIMP gives you the option to specify the bit depth of your BMP file when you export it. But yeah, so here's our source file, textreader.c. Then we got textreader.exe. So I'm going to go ahead and remove textreader.exe. Right. Yeah, so now we got Knox text. right wall and text reader.c. So we're going to do vi text reader.c. So I didn't do my alias. I'm going to alias vi to vim vi text reader.c. Yeah, so here's our source code right here. So I already had standard io.h imported just to do a print. It's a good thing just to try doing a print hello world after you install GCC, just to make sure you install the correct like executable and libraries and everything. But yeah, we're going to include SDL2, SDLH. Sometimes this is weird to get this set up correctly. It seems like in some environments it uses double quotes. Sometimes you don't put SDL2, but in this environment you do the full SDL2 and capitalize /SDL capitalize. I'm defining the number of characters per line to 32, a constant and a pound define. I'm also defining the width and height of the walls to be 32. I'm going to use an SDL window object for the window, SDL surface for the screen. Those are both initialized to null. So if we go over here and go down, so we've got a parse file method, but first it's going to call int main, then pass in int argc, number of arguments, comma char star args with array notation for our string. So this is one thing to watch out for with SDL. If you do int main void or leave these out, then it will complain. It'll think it's another definition of main. So make sure you got your int argc and char star args right there. So we're going to do SDL init, SDL init video. You really need to like put error checking around this, but just for this demo, I'm not. And by the way, all this is in my, as I mentioned before, SDL talk, SDL with C. Check that out for more details. We're going to have that window object, SDL create window, passing the title. These other parameters, window position undefined. Then our size, I'm just doing 1024 by 768. SDL window, make sure it's shown. We're going to create a SDL surface. That screen surface, get window surface, pass in the window object. So then we're going to use SDL fill rect to fill that surface just with blue, which is 0000FF. In hex, we're using the SDL underscore map RGB screen surface format to create that blue background. Then we're going to call our parse file method right here. So now we're going to go back up and look at our parse file. So went ahead and created an SDL surface for our wall. It's just going to be 32 by 32. You got to have an SDL rect for positioning that wall. So we're going to set the wall to SDL load BMP. Then we're just going to pass in a string constant SBR wall, the file name for our BMP file. Then we're going to set the width and height of a rectangle to what we defined it, which was 32 in wall width and wall height. So this is like I was talking about earlier. We're going to use a file pointer. I'm just going to do fopen Knox text in read mode. Then we're going to have our character string as an array, and that's where we have our charge per line, 32. And you can make that bigger if you need to. So we're going to have two ints, again, a row and a column, initialized to 0. Then we're going to have a while loop, while fgets. So fgets is going to read a whole line. So we're going to store that in stir line, the number of characters per line, and the reference to the file pointer. So while that does not equal null, we're going to keep looping. Then we're going to have another while I call is less than the characters per line. We're going to check and see if the character at that column equals a pound sign. If it does, then we're going to set the X and Y coordinates of the rectangle to, we're going to set X to the I call times wall width, and we're going to set Y to I row times wall height. And then we're just going to blit it to the screen, SDL blit surface, SBR wall. So the second parameter here is the source rectangle, which we're just going to leave as null. We want the whole 32-bit rectangle. Then we're going to blit that into the screen surface. Then we're going to pass in that reference to the rectangle. So this is the destination position rectangle. So for each character, we're going to increment the column using iCol++. Then after for each row, we're going to increment the row, iRow++, and then reset the column back to 0. So then after we're done reading all the rows, we're going to use fclose, pass in reference to the file. Then we're going to free that surface to the wall to make sure that we don't have a memory leak or anything. You can go into like your system settings, and if you don't free that up, then it'll start gobbling up memory. So after we're done parsing the file, we're going to do update window surface, passing the window. Then we're going to put in a 2-second delay using SDL delay, 2000 milliseconds. Then we're going to do SDL destroy a window, then SDL quit to quit the program. Put an extra return to 0. I don't even think that's really needed right now. So if we exit out, I'm just going to grab this right. But this is the command you use to compile. Like I said earlier, if you're using other SDL libraries, then you're going to have more .l library includes. But this SDL config right here, that's going to get all the basic ones that you need right there. So we're going to compile that. And if it compiles successfully, then it's just not going to give you any output at all. But if you do an ls-la, you will notice that you have the textreader.exe. So you can either type in textreader.exe or do // just text reader. So that creates our window there. Okay, so like I mentioned earlier, it's only going to display it for 2 seconds. So let's make this 60 seconds. So in a real game, but I have a loop to handle key presses and things like that. But I just want to make this simple. So I just have a delay there. I compiled it. Text reader. Yeah, we'd really have like a handler for closing. But yeah, there's our Knox right there. Blue background. Characters. But yeah, as I mentioned earlier, I don't even know if you can pull that. It really wants to go for the full 60 seconds. But you can edit that text file and change it however you want. Add new characters, whatever you need to do. And also, I'd go in like actually create a wall object or a wall structure. Do it that way instead of just doing the sprites. And by the way, this also works for C++. One example I'm not doing is Allegro. I think Allegro actually has its own methods for reading and writing files, but this also works for C++, which I don't remember off the top of my head. I think C++ is a little bit easier with its streams for reading files. I think it's IO stream, something like that. It's been a long time since I did file reading in C++. Go back to the slides. Yeah, so that's the code right here. Parse file and the main, and yeah, here I even put how to compile it right here. Want to make sure to put that in there. How to compile that. There's the example right there. Yeah, so that's going to be it for Knox Game Design for September 2022. Hope everyone found this presentation helpful. And hopefully next month we'll have some games maybe to show off. So until next time, see everyone back in a month.